Hello, in this video we're going to look at describing the three transformations. So this is the number 2 learning intention on your unit plan. So from last year we had three transformations. The first one we need to know is dilation. And if you imagine, if you've ever heard someone say like dilating pupils, that means they stretch out or get wider. So dilation, informally, I'm going to say stretching. Alright, what does dilation look like? So we're going to be building up a reference table here. So the important part will be the phrases. I'll point out the important part that you'll need to know. But basically, if you have some function, f of x, and that can be any function we described earlier, because we described 8 basic graphs or 8 basic functions. That could be any one of those. It could be quadratic, cubic, exponential, whatever. If we put a factor of a out the front, some number out the front a, if we think about it, every y value of that graph is being multiplied by that factor of a, which means they're getting stretched, and it's getting stretched away from the x-axis. So the thing we need to know is that if we have this, the way we say it is a dilation by a factor of a, like this a here, dilation by a factor of a from the x-axis. So even if you don't quite yet understand the mechanics that means this AF of x means this, for now you need to memorize it. You need to know that a times f of x means a dilation by a factor of a from the x-axis. And there's another one. We can take this argument here inside the function and we can multiply that by a. And we say that that is a dilation by a factor of 1 on a from the y-axis. Can you see how they're kind of the opposite of each other? This is by a factor of a, this is by a factor of 1 on a, this is from the x-axis, this is from the y-axis. So once again, when I was learning this, I found it very hard to understand the mechanics of it straight away. I learned these by rote, and later on I managed to understand exactly what was happening here. So the second transformation, and this is going to make up a reference table for you, is called reflection. And informally, I like to call reflection flipping. So it's flipping things around like a mirror would do. So it's going to be flipping our function around. Let's have a look at this. So how do we describe negative f of x? So you can imagine that, if f of x, say, was a parabola, negative f of x might be an upside down parabola. So it's flipping it, and that's flipping it in the y-axis. Sorry, that's flipping it in the x-axis. Let's draw it. Let's do a quick sketch. You don't have to sketch this, but let's see. So here, if this is f of x, and we make every value of f of x negative, well, it's going to look like that. So that's negative f of x, and that's flipping in the x-axis. there. Can you see that? So we're making every y value negative, so that's flipping in the x-axis. But we have to be able to state it formally. So when we see this negative sign out the front, we can say a reflection in the x-axis. Alright. And you noticed how these were kind of opposite? Well, you can imagine that f of negative x is going to be kind of opposite to this. So if negative f of x is a reflection in the x-axis, f of negative x is, yeah, you guessed it, a reflection in the y-axis. Alright, that's pretty good. We've got dilation, reflection. Now we have the last one, translation. Alright, what's translation? I'm going to call translation moving. It's moving things around. Let's move things around. So let's look at what happens if we take some function f of x and we add some number a. Well, each y value is going to be shifted up by a value of a. So if that's f of x plus a might be somewhere here, because everything's getting shifted up. So we call that translation. You don't have to write the a out the front, a dilation. You could just write dilation by a factor of a, or we could write a translation. That's not important, but we're going to say translation of a units up, like that. Now, if a happens to be a negative number, if a is negative, we're going to say translation of a units down. So we'll put a little note here. If a is negative, if a is negative, we'll say that it's translation of a units down. Translation of a units down. Alright, so you notice that this one kind of like, this one makes sense, and then this one's kind of counterintuitive, like it's one on a and it doesn't kind of make as much sense as that one. This one makes sense. This one, yeah, makes a bit of sense. This one makes sense, but the next one's going to be a bit funny as well. So whenever we're playing with the argument of the function, whenever we're playing directly with the x, so here we're playing directly with the x, here we're playing directly with the x, we're going to do it down here as well, it gets a bit funny. So we're going to do that. So that's a good way to kind of remember it. If you're playing directly with the x, things get a bit opposite. So let's have a look at that. If I have f of x plus a, now although this is saying plus a, you might think plus a moves it to the right. It actually moves it to the left. And you can check this on your graphics calculator. Yeah, it makes sense when you've done it several times, but for now you'll probably just have to accept it. So f of x plus a is a translation of a units to the left. The way I think about it is, if the x-axis were time, adding a makes it kind of happen sooner. That's how I think about it. It's adding time, so it happens earlier. That's one way to think about it. I don't know if that will help, but that's how it kind of makes sense to me. And once again, if A is negative, it's translation of A units to the right. Fantastic. All right. This is what I expect you to get out of this. I expect you to be able to write each one of these phrases from memory, and I expect you to be able to recognize each of these functional notations. So I expect you to be able to look at A times f of x and go, oh, that must be a dilation by a factor of A from the x-axis. Hopefully with practice, it'll come out of the wash and you'll see why all these things happen. But for now, you need to make sure you absolutely know it. So in the next video, to make this all make a bit more sense, we're going to be applying these two examples. And remember, this is for learning intention number 2. Finally, if you have been, thanks for watching.